401.167, right? That's the interval. That's part A. So part B is to interpret the confidence interval. What is this? 1.869? Okay. D value is 3.250, right? Okay. Now you have to interpret the confidence interval, right? How to interpret this interval? You can write, you can say like this. We are 99% confident that the true population mean weight of biscuit packets is in the interval of 394.56 and 401.1719, right? We are 99% confident that the true population mean weight weight of biscuit packets is in the interval of right. We are 99% confident that the true population mean weight of biscuit packets is in this interval. That's the interpretation for this confidence interval, right? It's okay. Yeah. Okay, question number 8. Right? Question number 8. So, with the question number 7, we put N for interval estimation for population mean, right? And question number 8, 9, and 10 is about building confidence interval for population proportions, right? Population proportion. Question number 8 is about population proportion, building confidence interval for population proportion, right? I think you discussed it this Monday, right? About the population, about building confidence interval for the population proportion, right? You may get another formula for confidence interval of population proportion, right? P hat sample proportion, it is the point estimate plus or minus Z value of alpha divided by 2 into, again, sample proportion P hat times 1 minus P hat, right? Divided by N square root, right? So this is the formula to find the confidence interval for population proportion. So this part is the point estimation and this part is the margin of error, right? Same as the mean one, right? Okay. So in question number 8, we have to use, from question number 8, we have to use this formula, right? Because we are dealing with population proportions, right? Not mean anymore, right? Okay. So a manufacturer, okay, first, pay attention to the formula. In order to use this formula, you have to know the P hat, sample proportion, right? And you have to know the N, sample size. And you have to know the alpha value, confidence level value, right? So those things you have to know before using this formula, right? Let's see. A manufacturer wants to assess the proportion of defective items in a large batch produced by a particular machine. So that large batch is the population, right? So he wants to assess the proportion of defective items in the population. He wants to assess the proportion of defective items in the population. He need to find the population proportion, right? He need to find the population proportion, right? And it says a random sample of 300 items is taken. Now he has taken a random sample. It is observed that 45 items of these 300 are defective, right? We are not directly given the sample proportion P hat, but we need to find it, right? Remember, x divided by n, x is the defective items, number of defective items 45 out of the sample size 300, right? So it would be 0.15. So P hat will be 0.15, the sample proportion of that sample of size 300, right? So we have find that. And now we have to construct a 95% confidence interval for the proportion of defective items in the complete batch. we have to find the 95% confidence interval for this P. Okay, now we have P hat here. Now we have N here and alpha divided by 2. This is 95% confidence interval. So alpha is 5% or just 0.05 and alpha divided by 2 is 0.025, right? Right? So I have to find the critical value is Z of 0.025, right? Okay. I will write again this formula. You have to remember the formula, right? Right. So P hat 0.15 plus or minus. What's Z of 0.025? Yeah, very good. 1.96 times 0.15 this. Then 1 minus P hat 1 minus 0.15. It's 0.85, right? Right. N was then here 300. And the square root of that, right? So 0.15. The rest is calculation, right? 0.0404. Or you can just write 3 decimal points is enough. 041, right? So P, population proportion, lies between 0.15 minus 0.041 and 0.15 plus 0.041, right? So the population proportion lies between 0.1096 and 0.1904, right? So what does this P mean? The proportion of defective items in that large batch produced by a particular machine that that manufacturer wants to assess, right? So now he can say that the population proportion lies between those two values, right? 0.96 and 0.1904. We are 95% confident that that population proportion he want to assess lies between this interval, right? Okay. Right. Then the question we have done in this tutorial of population proportion. So is there any question about that? You have to first find the sample proportion. You will be given the data enough to find the sample proportion, right? And you will be given sample size. You have to find alpha, Z alpha, and then use the formula, do your calculations and get the answer, right? Keep in mind that this is what we need to estimate using this, right? We need to estimate the range for this using this, right? Sample proportion. Estimate population proportion using sample proportion. So tell me, take another sample of 300 or another sample of different price. Would it be the same? Same estimate, same interval estimate for P. I'm marking. I'm taking another 300 or another figure. No, okay, very good. No, right? We got 100 samples of 300 size 300. We got 100 intervals, right? If we got 1000 samples of 300, what different samples we got? We will got thousands of different ranges. Now, is that okay? Can you hear me? Okay. Okay. I was talking. If we got another random sample of 300, okay, I'm back. Sorry for the issue. Um, can you hear me? Okay. 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 We stop at the question number 8, right? Uh, okay. Now do question number 9. It's also a population proportion question. Do question number 9, right? I will do it with you, right? Otherwise, you wouldn't do it. The telephone company has the business objective of wanting to estimate the proportion of households that would purchase an additional telephone line if it were made available at a substantially or whatever, right? Data collected from a random sample of 500 households, right? So that's an important part. Data collected from random sample of 500 households. The result indicate that 135 of the household would purchase the additional telephone line at a reduced cost, right? So we can find what we had. 135 out of 500 sample will satisfy the condition, right? So that's the population proportion. So it would be 0.27, right? So P hat, we know P hat, and we have to construct a 90% confidence interval estimate for the population proportion of households that would purchase the additional telephone line with the reduced cost, right? I have I have written the final answer in the previous question, right? Question number 8. I have written it, right? So whiteboard has been closed. So I'm now at a new whiteboard. But I can remember I did write the final answer 0.10962, 0.1904. That's the interval of question number 8, right? Okay. Right. So in question number 9, these are the data that we have to deal with. And this is the formula we have to use. P hat 1 minus P hat divided by N. Right. So what's the alpha here? In question number 9, the confidence level is 90%. So alpha is 10% or just 0.1. So alpha divided by 2 is 0.05, right? So how to find the Z of 0.05. So P is 0.27 that we have just found out, right? Here, that's a sample proportion. And Z of 0.05. P is 0.27. 1 minus 0.27 is 0.73, right? And N is 500. That's it. So what is the Z value? 1.645, right? This value, right? Zero, 3, 2, 7. So P lies between 0.27 minus 0.033 to 0.27 plus 0.033, right? So the range will be, the interval will be this is together 0.2373 or 237 to 0.323, right? 95% confidence interval for P in this case is that. Formula is what matters, right? Sample proportion we have to find out. We said alpha will be given, n will be given, right? To find the range for population proportion. It's so that means we are 95% confidence that this population proportion will lie between this range, right? So what's the population proportion in this specific case? Population proportion of households that would purchase an additional telephone line if it were made at reduced installation cost lies between this value, right? Okay, that's the question number 9. Yeah, very good. The telephone company can be 90% confident that, okay, there is an answer, that the true population of all households that would purchase an additional line at reduced cost is between, yeah, we can write it with percentage, but since this, interpretation, you can write that it as percentage, right? 23.7% and 30.3%, right? Good. So that's the question number 9. Right. Since we have time, let's do the last question as well, right? For a class project, a political science student at a large university wants to estimate the percent of students who are registered voters. So that student needs to know the percent of students who are registered voters, that means population proportion. He need to find it. He surveys 500 students and finds that 300 are registered voters out of this 5. So in that sample, the sample proportion is 300 out of 500, right? So 0.6, right? Right? Oh, yeah. Okay. You have to find 99% confidence interval for the true percent of students who are registered voters. True percent mean that population proportion. And interpret the confidence interval. Plus or minus, this is a point estimation. Plus or minus marginal error. Marginal error will be Z alpha divided by 2 p hat 1 minus p hat divided by n square root, right? So p hat will be, we have found out it's 0.6 plus or minus Z 99% confidence interval mean alpha mean 1%, 0.01. Alpha divided by 2 will be 0.005, right? So Z of 0.005 and this P. So that means this is the value is uh, 2.575, isn't it? Is that correct? It said 0.005 is 2.575, right? And 0.6, okay. And 1 minus we had 0.4. And N is 500. So that's 8. We are almost at the answer. 0.0564. 3 decimal points is enough. Yep. Minus 0.056 to 0.6 plus 0.056. So that means 0.54364. Yeah. 2656. Right. And you have to interpret it. So you will say, we are 99% confident that the 2% of students who are registered voters is in the interval of this, right? 0.544 and 0.656. Right. Okay. This is the form of proportion, right? So we have 3 formulas altogether, right? Population for me, you have 2 formulas. One is sigma known, one is sigma unknown. And then for proportion, population proportion, you have another 1 formula. So together 3 formulas. That means that sometimes you may be not ask the confidence to construct the confidence interval, but you have to find the margin of error. In that case, you have to consider only this part, right? This part. So that's the margin of error. Together with the point estimation, it makes a confidence interval. But if you are asked about or only to find the margin of error, you have to find this part only, right? Okay. Is there any question about what we have done today? Is there any question? Next week you will have a quiz. I think it's from sampling, distribution and sampling part, the first quiz. And in the next week you will have another quiz from confidence interval estimation. And the last quiz will be in the following week from hypothesis, right? Dr. Sankar have answers for this tutorial 9. Okay, okay, I will. But I have done almost all the questions today, right? මම answers upload කරේ මම අර revisions question එකක්වත් කරේ නෑනේ class එකේදී. So that's why I upload those answer sheets. But okay, I will upload, right? Because today participation is also very low. Like half of the people are not here. So I will upload, right? Okay. Prepare for the quiz. And next day, 6th of May, right? Next week, next Wednesday, 6th of May, in the first half of the session from 8:15 to like 9:30, you will have the tutorial session, and after 9:30 or 9:15, you will have the quiz one, right? So prepare for the quiz. The details are in the mail. The details are in the mail. Check your mails. Right. And the next thing is, next important thing is, in the models for all the subjects, you will be updated about feedback forums, right? You have to complete those feedback forums, right? Check all the modules that you are currently enrolling, and you can complete those feedback forums, right? Everyone should do it, right? It's better to do it within this week. Okay, that's it for today. If you don't have any question, let's wrap up the session. Let's meet physically from next week, 4th of May, right? Thank you for participating. Have a nice day. Okay.